All right, here it is, lesson number 5. Buckle up because this one's going to be a crazy ride. Be prepared because this is the moment you've all been waiting for. This is putting all of the pieces together. This is the biggest, baddest problems that we're going to see in this entire unit. And what a way to go out. So if we take a look here, just like has been the same for the past 4 lessons, we start with a list of steps and no craziness here. Everything is something you've seen before. We're going to basically be following those same steps that we did. It's just the variety that you're going to see in these problems that's going to look a little bit different. So the big thing is that step 1, now we're going to see that our denominators are actually going to be factorable. Not always, but for at least some of them. So that's going to affect our LCD work, unlike in lesson 4 where we could just kind of see it right out the gate. So let's get straight into it. Example 1, we are looking at 3 fractions, which is new. And if we analyze each of the denominators, the first one, I see 2 x's within the 2 terms. So I'm going to factor that out using GCF. So we'll have x times x minus 2. The other 2 denominators of x and x minus 2 are not factorable. So that part is done. Next step, I'm going to identify, because we're going to need this here at the end, where do we have problems? And again, that's where does the denominator equal 0. So if I look at just the first one right here, if x is 0, that's going to be an issue because of this x right here as well as this x right here. So 0 is a problem. And if I look back at the first denominator, x minus 2, well, if x is 2, that's another issue because that denominator will go to 0. And then the same thing, this would also be a problem if it were 2 over here. Other than that, there's no other domain restrictions. So we just want to make sure at the end that 0 and 2 are not part of our final answer. Now for LCD, remember that we haven't done this in the last lesson, but we want to highlight things that they share in common. So I see an x here and I see an x here. I also see an x minus 2 here and an x minus 2 here. And if you look, we just highlighted everything. So for my LCD, I need an x for the red highlight and I need an x minus 2 for the green highlight, and that's it. There's nothing extra that I need to tack on to those 2 factors. So the the lowest common denominator here is going to be x times x minus 2. All right, now a little bit different strategy this time because there's 3 fractions. So I'm actually going to multiply every term by that LCD the whole way through. And I'm going to write this again a little bit differently than I did in the last lesson. So our LCD is x times x minus 2. And we're multiplying that by our first fraction of 10 over x times x minus 2. Then we've got added on to that the 4 over x. So I'm going to multiply that by x times x minus 2 and times 4 over x. And that equals, again, our LCD times the fraction that was there, 5 over x minus 2. So now, again, just like in the last video, what should happen here is that a lot of things in this particular step should cancel. So notice in the first one, everything in the denominator cancels out because x times x minus 2 is the LCD in that denominator. In our second set, the outside x and the bottom x can cancel, but we do have to do the multiplication here yet. And then for the last one, x minus 2 and x minus 2 are top and bottom, but we have to multiply the 5 and the x. So at this point, let's clean it up a little bit. So now we have first fraction, just a 10, plus, all right, 4 times x minus 2 will distribute. So we'll have 4x minus 8. And then equals, we're just multiplying 5 times x. Now, good news here. I don't see any x squared terms, so that means I probably won't have to factor, but I do need to finish solving this one out. So let's get like terms combined. We can combine the 10 and the negative 8 to make 2 plus 4x equals 5x. We'll subtract over the 4x, so we literally get 2 equals x. And you would think that that means we are finished, but step 5, we have to verify that this is not an excluded value, and wait for it. Look back up at our excluded values. 2 is one of them. So what in the world does that mean here? That means that there's no solution, because the only answer that we got is an excluded value. So if I plug 2 back in, I'm going to get an undefined value, because I'm going to have a 0 in the denominator. So example 1 done. No solution is our final answer. Let's take a look at example 2. All right, so example 2, again, we can see here that we've got 3 fractions yet again. First step is, again, going to be to factor each of the denominators wherever possible. So z minus 3 and z plus 3 on the two ends, they're done, but z squared minus 9 is factorable. So I'll just write that underneath. That is a dots problem, z plus 3 and z minus 3. And that's great, because when I grab my highlighter for the next step of finding the LCD, we'll take care of that right away. Here's a z plus 3 here and here. And here's a z minus 3 here and here. So the LCD, just like the last one, is just 2 factors. So we need an LCD of z plus 3, z minus 3. And now, since I found the least common denominator, finding the excluded values is actually easier, because I don't have to look at each denominator individually. If I set each of these factors, z plus 3 and z minus 3, equal to 0, I'm going to get a positive 3 and a negative 3. So at the end, if this time our answers are positive 3 and negative 3, or any combination of those two, then this would also be a no solution. So let's see what happens. So we factored, we found our domain restrictions, we found the LCD. Next step is to multiply every term by that LCD. So I'm going to rewrite that line. So LCD is z plus 3 times z minus 3 times the first term, which is negative z minus 3 over z minus 3. Then we add on the next term, but LCD first. And our next term is 11z plus 3 all over. I'm going to write it in that factored form so we can see the cancellation that's going to occur here. And then that's equal to our LCD times 1 minus 5z over z plus 3. All right. Now we're hoping that a ton of this cancels out, right? So in the first term, we've got a z minus 3 over z minus 3. Those cancel, but we do need to multiply those two binomials. Then we have a z plus 3, z minus 3. Those both cancel out, so that's great for that one. So this is literally what we're going to get out of the next term. And then the last one on the right, z plus 3 and z plus 3, top and bottom. So here we have to multiply those two together. So in this case, I've been using FOIL a lot in the previous videos. I'm actually going to show the box for the next step. So let's move this up so we have a little more space. For the first term, so if we drop this down right here, we would have a 2 by 2 box. And on the top, maybe I put the z and the 3. On the side, we need negative z and negative 3. And the way we work the box is multiply the sides to get in, and then we add to get out. So we would have negative z squared, then negative 3z, another negative 3z in this box, and then negative 9 down here. So our first term, when we multiplied all of this together, becomes negative z squared minus 3z minus 3z minus 9. So lots of negative values there. Now, the second value, we don't even need a box. We can just go straight down to it. We're adding on the 11z plus 3 because the denominator and the LCD just canceled out. And then that's going to equal our last term But in this case, we do need a box. We have z minus 3 times 1 minus 5z. So another 2 by 2 box. And we'll put z and negative 3 across the top, and then 1 and negative 5z on the side, and then multiply to get in. So 1 times z is 1z, or just z. 1 times negative 3 is just negative 3. Negative 5z times z is negative 5z squared. And then negative 5z times negative 3 gets me 15z. All right, so out of the box then we get a 1z minus 3 minus 5z squared plus 15z. All right, and now we can combine like terms a little bit. So on the left-hand side, we don't have any other z squared, so we'll leave that go. We've got negative 3z, and 11z, so that ends up being positive 5z. And then we got negative 9 and positive 3. We get negative 6. All right, on the right-hand side, we can combine the z terms. I'm going to order this and put the negative 5z squared first. And then 1z and 15z gets me 16z. And then a negative 3 on the end. Now, at this point, note that we've got z squareds. Well, we've got one of everything on both sides. So we need to choose a side to get everything on, because if we need to factor, because the z squared term doesn't cancel out in this case, we need it to be equal to 0. Now, remember the rule that we've been talking about. You want to make the z squared term positive. Well, right now, both of them are negative. So how do I decide on which side? Well, think if I add the z squared this way, that would be negative 5 plus 1. That's still going to be negative. So let's not add that way. If I add 5z squared over here, I'll get 4z squared, and now we've got our positive value, not cubed squared. And then plus 5z minus 6, still equal to 16z minus 3 at this point. And now I just want to take those other two terms, since I've chosen a side, I want to take those to the left as well. So I'm going to subtract over the 16z, and while I'm at it, I'm going to add over the 3 right away too. So once we do that, we will have 4z squared, let's see, minus 11z, and then we'll have minus 3 equals 0. And at this point, again, we already mentioned it, this is a trinomial with a squared term, so we are going to have to factor. So negative 12 would be our top value, negative 11 on the bottom, two numbers that multiply to negative 12 but add to negative 11. We're looking at negative 12 and positive 1. So our factoring step would be 4z squared minus 12z plus 1z minus 3. Group, and we can take out a 4z here. So we'll be left with z minus 3. And that's already pretty much in place, so I'm just going to put plus 1, and there's our z minus 3. So our factors that we can then set equal to 0 are going to be z minus 3 and 4z plus 1. All right, 1.5 more steps. So we got to set z minus 3 equal to 0 and solve, and 4z plus 1 equal to 0 and solve. So our z over here would be positive 3. And then we'll subtract the 1, divide by 4. We're looking at negative 1/4. So this problem was huge. because it's basically taking me an entire sheet of paper to do it. So we got to scroll back up here. So we got z was 3 and negative 1/4. We got to go check those excluded values. And here they are. Positive 3 and negative 3. So if we come back down, positive 3, negative 3, and of course, we did get a positive 3. So this would not be a solution, but negative 1/4 will be. So if you want to note that a little bit different, but know that I don't want to see 3 as part of your answer. I only want to see the negative 1/4. So somehow you have to indicate that it was not part of it. All right, let's move on to example 3. And here we go. So example 3, I want you to pause the video and try factoring and finding the domain restrictions and the LCD for this one. Okay, so coming back to the video real quick, you should have x plus 2, x minus 2. In this case, we can highlight and see that there's an x plus 2 that's repeated here. But then we also have something that's not highlighted here. Also note, I'm going to circle it here. This 1 kind of sneaks in there. Don't forget about that. Technically, that's 1/1. So when we're writing our LCD, we know that we need x plus 2 because that was a highlighted factor. We also see that there's an x minus 2 that was unhighlighted, and technically there's a denominator of 1, but if I choose to write that, it's not going to change anything. So I don't have to worry about that for the LCD. Excluded values, so we can come up and check those later. X plus 2 will get me a negative 2. X minus 2 will get me a positive 2. So we don't want to see a 2 or a negative 2 as part of our solution set. And now we get into the big step where we have to multiply everything by our LCD. So LCD was x plus 2, x minus 2, and we're multiplying that by the 10 over x. Again, I'm going to write the factored form here, x plus 2, x minus 2. Again, don't forget here the 1, so next step would be to do x plus 2, x minus 2, technically times 1/1, right? And then we have a minus here. And again, I always like to add the opposite, so I'm going to write that up here. So now when we come back down, we can do plus the LCD x plus 2, x minus 2, times negative 1 over x plus 2. All right. Again, we're looking for lots to cancel here. On the left, x plus 2 and x minus 2 are in the top and the bottom. They cancel out. So literally, we just have this 10 left over here. In the second fraction, we have x plus 2 times x minus 2 all times 1. So really, we just got to FOIL or box that. And then the last one, we have x plus 2 top and bottom, so they cancel. We just need to distribute the negative 1 in here. So let's move that up a little bit. When we go to rewrite this thing, first one, we get a 10 equals. Next one, we need to do the box or FOIL, whatever your preference. So x and 2, x and negative 2. So we would get x squared, 2x, negative 2x, and negative 4. Awesome news here. The middle terms cancel because we got positive negative 2. So we literally get x squared minus 4 out of that box. And then the last term will distribute, and we get negative 1 times x minus 2. So that would give us negative x plus 2. Here again, I can combine like terms, and I see an x squared. I see that there's only one x squared, so I'm not going to get it to cancel, which means I want to move everything to one side of the equation so I can get it to equal 0. In this case, I'm going to do the odd thing, which is move the 10 this way. We don't typically do that, but to keep the x squared positive, that's what I'm going to do. So let's combine like terms quickly. Get x squared minus x minus 2, and then we can subtract the 10, so we get x squared minus x minus 12. And now we have to factor. So we need the x. Top number, again, is a negative 12. Bottom number this time is only a negative 1. So two numbers that multiply to negative 12 but add to negative 1. should be -4 and +3. So putting that back in, we've got x squared minus 4x plus 3x minus 12. Go to our grouping technique. Take out an x for the first two factors. Take out a 3 for the second two factors. And we have 0 equals, factor 1 is x minus 4. Factor 2 is x plus 3. So when we set each of those equal to 0, here we'll get +4. And here we will get -3. One last thing to do, and that's to go back up to our excluded values. They were positive and -2 from all the way up here. If we come back down, positive, -2 are not either of our answers. So you can either circle it in, or I had showed you with factoring that you can write it as one expression, or one equation rather. Either way, but -3 and 4 are both solutions in this case. So we saw a no solution in example 1, we saw a 1 solution in example 2, and now we've seen a 2 solution for example 3. Let's see what example 4 has in store for us. All right, so example 4. Again, if you want to, you can pause the video and try the first couple steps on your own. Or you can work through the entire problem on your own and come back and just check it with me at the end. First thing is to factor. I notice here that we've got a trinomial over here. These two are already just simply factored and ready to roll. So I do want you, if you didn't already, to pause the video and factor it and come back once you've done so. All right, so you should have factored the trinomial and found out that it is t plus 2, t minus 1. If you need help with that factoring, let me know. I'll gladly assist you. What we want to do at this point is find our LCD. So I can highlight the things in common. So I see a t plus 2, t plus 2. And again, there's repetition here. And then the big thing to note is that there's nothing in addition to that. So our LCD is just t plus 2 and t minus 1. Now, t cannot equal, in this case, think about it, what are the things that are going to produce zeros here? -2 and +1 from each of those factors. All right, and now we multiply every single fraction by the LCD. So LCD is t plus 2, t minus 1, times t over t minus 1. And we've got t plus 2 times t minus 1 times 1 over t plus 2. And then we're adding on t plus 2, t minus 1 times 3 over t plus 2, t minus 1. And grab your different color. Now we get to cancel things out. So first fraction, there's a t plus 1 top and bottom. Second fraction, t plus 2 top and bottom. Third fraction, our favorite. Everything top and bottom cancels, except don't forget about this little 3 that is still there. All right, next up, we want to identify our multiplication that we have to do here. So what's left over? So for this first one, we're going to distribute the t. The second one, we can distribute the 1, but that doesn't really change much. And we already mentioned the third one, we just have this +3. So not too bad this time. No boxes needed, which is thankful for that. For the first one, when we distribute t times t will give me t squared. T times 2 will give me 2t. All right, that's the left-hand side of the equation. Multiplying by 1 just leaves this t minus 1 for the second one right here. And then we need the +3 on the end from the last fraction. Again, I noticed that there's a t squared here. It is positive already, and there's no other terms to cancel or to add to it. So I want to move everything in this case to the left to keep the t squared a positive value. So we can have t squared And then we'll get, let's see, we'll subtract over the t, so we get plus t. This would equal plus 2, so we need to subtract over a 2 to keep it, to solve the equation there and get 0. And again, we're down to a trinomial, which we need to factor. Now, hopefully, maybe you notice that this trinomial and the original trinomial are identical. So the factoring that you did at the beginning, you don't have to do it again because we already found it. The factors here are t plus 2, t minus 1, set those equal to 0, and maybe you're already thinking ahead what's going to happen. If I tear it apart and set each of them equal to 0, what are the two quote-unquote solutions I'm going to get? Well, here I'll get negative 2. Here I'll get positive 1, but if we move this up a little bit, here's our excluded values. What do we notice about these? They're identical because the factors were identical and we solved and set it equal to 0 both times. So what does this mean about our answer? Well, it means I'm going to pull out a third color here and write it in big bold letters. This is a no solution. So don't be confused here. I circled the factors above, but they don't work. Cross them out because they're excluded values. So again, they'll create an undefined piece for us if we plug them back in. So no solution for this one again. All right. So at this point, you're going to see over the course of the next couple of days, we've broken it down so you only have to do 2 problems per day on these because they are quite tasking and we understand that. Please, please, please reference the extra practice problems that Miss Frederick posted. See how she's doing things as well for some extra practice and examples to look at. And let us know and reach out if you have absolutely any questions. This would be a great time to be checking in for office hours if you need help. All right. Good luck.